Hi everyone, my name is Thomas Kim. Today is May 31st, 2019. This is my 25th episode about the future of C++ programming language, C++ 2A standard. In this episode, we will learn about partial types, template member types or class, template friend class, template non-static member function, and static template member function. C++ language is very powerful, but its powerfulness is not free. We have to pay its due price to take advantage of C++ language. The syntax of C++ language is pretty much complicated. I will try to make it as simple as possible, but please keep in mind that you have to try all these features of C++ by yourself. Please follow my videos and type in the source code by yourself and build your program as I do, and try to have complete understanding how I do this. To follow this episode, please visit extensiontalkplayfun.com website. You can always download complete source code by clicking this link. If you are new audience to my YouTube channel, then you have to also watch this video. By watching this video, setting system environment variables for Visual C++ and GNU G++, you have to make proper system environment variable settings. Otherwise, you probably cannot follow this episode. Also, if you haven't installed Visual Studio Tools or GNU G++ or Clang, you can watch these videos about how to make development system. Click this button, Show in Folder. If you unzip it, you can find the CPP extension folder. If you double click it, you can find the tutorial folders. In this tutorial folder, you can find C++ source code for our previous episode. Also in CPP extension folder, there is an include folder. In this include folder, there is some library files. I will try to explain as much as possible about these libraries, how to implement, how to use. But these libraries are still in progress. What I mean is these are not completed and not documented well. This is the primary website for these libraries, and I am actively working on these libraries. I will try to make complete documentation and also try to show you how to implement them, but some libraries are much more advanced. For example, set operations. These libraries are quite advanced from my point of view, but I will try to how to implement, how to use, things like that. Also, I will make complete documentations, and you can always find the complete source code like this. For example, NCNR, permutation, combination, things like that. You can always find the complete source code. If you click this button, you can find how I implemented all these things. For example, rational number, you can find how I implemented rational numbers too. It's still blank, but in this case, I implemented rational number for positive rational number. I will explain all these things. I will try to explain all these things, also how to implement. But in some libraries, it requires some advanced mathematical understanding. So in future sessions, I will try to explain one by one, also how to use things like that. Start Visual Studio Code. Please copy CPP extension folder, right click, copy or cut, then paste it to your working folder. Paste, okay? Then open CPP extension root folder or CPP extension folder in Visual Studio Code. If you open it, under CPP extension root folder, you can find the tutorials folder. Click this tutorials folder, then click this button, O25 template members.cpp, hit enter, Ctrl V, then close this welcome file, include IO stream. We will make it simple in this episode because this episode can be a little bit complex for you. First, I will explain what is a partial type. Partial type. Types that are declared but not defined yet. For example, if we declare type like this, template, type name, element type A, class type A, this is a partial type. We haven't defined type definition yet. Okay? And another thing, INTA, it is declaration. Declaration, but we have not defined the element count of array of type int. So A is still a partial type. In C++, type void is also regarded as a partial type. Now let's keep going. Template, type name, element type A, class type A, don't forget semicolon here. I declare another class, template, type name, element type B, class type B. Okay, now I create a member here, private, element type A, member data, public, here also private, element type B, M data. Please note that this type B is template parameter. Also here type A is template parameter. Now we are creating a function. This is template function. Template, type name, element type B, void operation over type B. Okay, then here type B, element type B, std cout B. Since B defines this is type B, type B defines element type member data, we say M data. std and there. Okay, in the same manner, public template type name, element type A, void operation over type A, type A, element type A. We create the same function std cout A. Also has member data type std and there. I hope you understand up to this point. This type A and type B are template class, has very similar structure. First, note that this type V is not yet declared. In C++, name should be declared before its use. Okay? In this case, type V is not declared at this point. So it is a syntax error. So I will copy this. I copied it and I declare it here. Like this. This is partial declaration. The type of type V is not yet defined. Okay? So here type B has member data and data, but it is in private section. So if we want to access, then it needs to declare friend like this. Friend, it should be template, type name, element type B, friend, type B, it should be class. We have to declare like this. Also in this function, we are accessing member M data, but M data is declared in private section. So we also need to declare friendship like this. Friend, template, type name, element type A. You can just say element type, class type A. Okay, we have to declare friendship like this, but this is a syntax error. This is syntax error because friend should not come before template. Keyword friend should not come before template clause. This is template clause. Okay, this part is called the template clause. Template clause. Okay, this part is called the template clause. So this part is also template clause. This part is called the template clause. So this is correct syntax, but this is incorrect because friend comes before template. We have to fix like this. Template, type name, element type, friend, class, type A. This is the correct type declaration of friend. Now also I will change it to like this to help you easily understand. So now we can access this private member. Okay. Now let's create a function void test template non-static member function int main. We will call this function copy and paste. In this function, type A int A, type B int B. I declared two instances. One is of type A, an instance of this class. Another is type B, an instance of this class. Now start your command prompt. You should be in CPP extension tutorial subfolder. This start 025 template members. We will be using clang, std, C++17, 025 template members CPP, hit enter. Okay, it compiled successfully in C++. Template members that are not used are not instantiated. Okay? In this case, we haven't called this function yet, and we haven't called this function yet. This is template member of type V. This template is different. I will modify like this, okay, for easier understanding. Like this. Also, I will modify template parameter. This function, operation of type V, is not yet used. Operation of type A is not yet used. So we will use A. Operation of type V. Sorry, I have to copy, cut, paste. We provide V here. B. Operation of A. Okay. Now we are using operation of type V, this template member function. The code is generated now. Now let's build. We are using Gnu Compiler. Hit enter. A. Now it works, but we have some garbage value. So I will initialize to default value like this. In type A, in type B with the default value 2. Now let's build again. Okay, Gnu Compiler works. Now let's try with GNU Compiler. GNU Compiler also works. In case of Microsoft, CL EHSC STD C++ 17 025 template members CPP FE AEXE. Hit enter. A. Microsoft Compiler also works. I will add a constructor for this type like this. I copy and pasted element type A, B, element type A with the default value colon M data V. Then I created a constructor. In the same manner, I will create constructor for type B. Copied, pasted element type B, element type B, colon M data B. We created a constructor. Now this is template member function. Because this template parameter is different, this is called in class template member definition. Okay. Also in this case, in class template member definition. Okay. In some complicated situation, for example, I defined some type template, type name type, using element t. We made a simple type alias using type alias like this. Now in this function, in this member function, we want to use this type, okay, like this. Here, template, type name, type, sum, type A, type B. We declared member template declared but not defined. So we copy this function we want to define out of this class after this class here. Okay, now let's think about this. This is member function of type A. Okay, so I need to provide type A, but this type A, it means sum is member function of type A, but this is template class itself. So I say element type A, for example. Then I have to define element type A. Then here at the outer scope, template type name, element type A, like this. And this is some function returns type. We have to return type, for example auto. Okay, auto is not yet defined. Then here we can say auto. Then here we are using element t. We can make it something else. For example, I will create a struct template type name, type, struct, element t. I will delete this. Then it has member, type, and data. I declared a struct like this. Now here s, I declared s like this. Then we can say a plus b. Then we can return. Okay, we are returning this element type. Okay, because we defined this function, we defined element type here, and for some reason we cannot move before this type A. Then we want to define some function, and this some function returns this element type. So we have to define this sum after this type. This is out of class definition of type A, element type A, sum, type. This is out of class definition. Please understand that this element type comes from this template first clause, and parameter type comes from here. I hope you understand this syntax. Here we don't need s. Okay? Now let's try this function. Void test out of class definition. Okay? So type A, int A. We declared A like this. Auto RLT A sum 4 plus 6. Okay, please note that sum returns element t type. Why is squiggle? Sorry, we have to define type here. Type like this. It returns element type t. Element t type. So here we can print out like this: std cout rlt m data. Std and there. Okay. Now I copy this function. Copy. Paste. I will disable it. Here I say sum of 4 and 6. I modified like this. We are using Gnu Compiler. Okay, sum of 4 and 6 equals 10. So sometimes we need this syntax out of class definition, because if we are going to use this element type. In the same manner, we can define static member function too. In class type A, we are defining some static member function like this: template, type name, type name, types, or summation, type first, types, args, return, first, operator, 3 ellipses. This is parameter expansion. Then args. We need keyword static. Okay, this is in class static member function definition. Okay, in class B, I will create another static template function like this: template, type name, first, type name, types. I would say type, or products, type, first, types, args. This is declaration. We need keyword static here. Static member declaration. I copy this static member, copied, and I will define it here. This static member belongs to this type B, and I append here. It means this product is a member of type B. So we have to provide a type like this: element type, for example. Then we have to declare template, type name, element type. Okay, we defined this, and we have to remove static here. Okay, we remove the static like this, and here return. First is this argument, operator is multiplication, args like this. This is product. Out of class static member function definition. Okay, now we will create another function, void test out of class static member functions. Now we try this summation first. This is in type A, static class, static function. We need to provide type A. We can provide any type, double. Okay. Then summation. We can provide 1, 2, 3, 4, 5. Okay. Auto RLT says summation. Okay. Now another one, auto product. Now this comes from this type V. Here 1, 2, 3, 4, 5 factorial. Okay, it belongs to type V. It can be anything like this. Okay, now we can display std cout summation 1 to 5 summation std and then std cout product 1 to 5 product std and okay, now I copy this function, pasted it here. I will disable it in the command prompt. So we have to give C++ 17 standard CLS, so the result is displayed properly. I will remind you one thing important. When the template member is complex, such that C++ parser or C++ compiler fails to parse the syntax properly, in such case you have to prepend keyword template in front of the member template as below. Say, let's see. Please note that operation over type V is template member. In some case, when this function is complex, C++ compiler fails, then we have to prepend in front of this template member keyword template. Okay, this is also template. We have to append the template. Also, some is template member. Here, some is template member. When the template member is complex, C++ fails to parse. Okay, in such case, you have to provide template in front of template member. Also here, this static template member, when the C++ compiler fails to parse, then you have to provide template keyword here in front of template member. Also, this is template member. You have to provide template keyword if the compiler fails to parse successfully. Now let's try again. I built using Clang. Now let's try with Microsoft, with GNU. GNU also works successfully. Okay, Microsoft, using Microsoft Compiler CL, EHSC, STD, C++17, O25, template members, CPP, FE, AEXE, hit enter. So in case of Microsoft 117, it fails to build. Okay, 117, it failed. Also 107. So in this case, now let's try with Clang. This is Clang compiler. Clang compiler works. Microsoft fails. Okay, Microsoft fails, then append like this. You can fix like this. Now let's try. It should also be probably fixed like this. And now let's try. 117. In case of Microsoft compiler, it fails, so we remove this. I will also remove this. Okay, now it works. So when the parser fails to build properly, you have to provide template keyword in front of template member. Or you can do like this too. So if you see keyword template in front of some function or some member, then don't worry about this. I originally planned to talk about partial types. I addressed a little bit about partial type in this episode. And also I want to talk about template member types and template member class and template friend class, template non-static member function, static template member function. I think I covered all but these. This session become too long, and my next episode I will talk about the template member types and template member class, and also I will compare partial types declaration and primary template declaration. Don't fail to watch my next video. Please subscribe to my YouTube channel. Thank you for watching.